The universe is vast, a place of wonders and mysteries. Among the stars, countless worlds orbit countless suns. But not every world fits the mold. Some planets break the rules, defying gravity, orbit, and even our understanding of physics. They vanish from view, only to reappear years later. They swing so close to their star they become living infernos, or they dance dangerously close to neighboring planets, risking cosmic collisions. These are the universe's anomalies, worlds that challenge our knowledge and expand our curiosity. Join me as we explore these strange places. The most anomalous planets ever discovered, a journey to the edge of what we know and beyond. Kepler 413b is a planet that doesn't play by the rules. A world that vanishes from view, then reappears just as suddenly. It all started in 2009. Astronomers scanning the skies with the Kepler Space Telescope noticed a faint, telltale dip in the brightness of a distant star, Kepler 413. A transit, they thought, a routine planet crossing in front of its star. Calculations suggested it was a cool gas giant, a mass roughly 25 times that of Earth, its radius about 40% that of Jupiter. A typical exoplanet by all accounts. But then, something strange happened. A second transit was expected 180 days later. It never came. No shadow, no dimming, no sign of the planet at all. It was as if Kepler 413b had simply vanished. Theories emerged like cosmic riddles. Was it a dark spot on the star's surface, a trick of light, a cloud of dust passing between us and the star? But every explanation dissolved under scrutiny. Then, after 800 days, the planet reappeared. A dark silhouette once again crossed the star's disk. Kepler 413b had returned, only to vanish again after a brief cosmic cameo. But how could a planet hide, then emerge, then vanish again? The answer lies in the planet's extraordinary orbit. Kepler 413b is caught in a gravitational tug-of-war between two stars, a pair of suns, locked together in a binary embrace. The planet orbits this pair at a distance of 36 astronomical units from their center of mass. But the gravitational ballet between the two stars creates a cosmic imbalance. Their combined gravity tilts Kepler 413b's orbit, like a spinning top, swaying side to side. This oscillation, 2.5 degrees in each direction, means that at times, the planet's path tilts out of view from Earth entirely. Imagine that. A planet whose orbit is so skewed that it regularly disappears from our vantage point, a world playing hide and seek with the universe. But the mysteries of Kepler 413b don't stop there. Its own axis of rotation tilts wildly, up to 30 degrees. Combined with an eccentric, shifting orbit, this means that the climate on Kepler 413b is anything but predictable. Some days, its poles bask in sunlight. Other times, the equator is the only place warmed by its parent star. This constant change whips the atmosphere into a frenzy. Planetary-scale hurricanes, bigger than anything on Earth or even Jupiter, spin across its skies. Ice clouds are swept along at thousands of kilometers per hour. When these atmospheric rivers collide, the energy released can rip the upper layers of the planet's atmosphere, flinging them into space before gravity pulls them back. Lightning storms rage, illuminating the darkness like cosmic fireworks. Imagine a storm so massive its lightning bolts could be seen from space.
And that's just the atmosphere.
Deeper down, the planet's interior is likely a maelstrom of pressures and temperatures. The constant gravitational tugging from the twin stars may squeeze and stretch the planet's core, heating it from the inside. Perhaps, below the clouds, vast oceans of liquid metallic hydrogen swirl, like in the depths of Jupiter. It's a place of extremes, where day and night, summer and winter, are terms that have no meaning. A world where order and chaos coexist, every sunrise bringing a new kind of sky. Yet, in its own chaotic rhythm, Kepler 413b is a testament to the laws of physics, a reminder that even in the most unpredictable corners of the cosmos, the universe is dancing to a tune we're only just beginning to hear. In the darkness between the stars, Kepler 413b stands as a beacon of mystery, a planet that challenges our assumptions and invites us to wonder what other secrets might be hidden in the cosmic shadows. Some planets are born in chaos, forged in cosmic violence. HD 8066b is one of those worlds. Orbiting a yellow dwarf star, one not so different from our own Sun, this planet is a gas giant, 4 times the mass of Jupiter. But unlike Jupiter, it doesn't follow a gentle, circular orbit. Its path around its star is a cosmic slingshot, stretched and distorted by forces beyond comprehension. At its farthest point, HD 8066b drifts at 88 astronomical units, a distance so vast that the star's warmth barely reaches it. Temperatures there would be cold enough to freeze even the most stubborn gases, a quiet, frigid world drifting in the darkness. But then, the quiet ends. Every 111 days, the planet hurtles toward its star, pulled by the star's relentless gravity. In a matter of days, it plunges from the deep freeze of space to the furnace of a star's embrace. Its distance shrinks by a factor of 30, from the edge of the system to a perilous near-star flyby. The result? A transformation unlike anything else in the cosmos. The energy it receives from its star increases 800-fold. Temperatures on the planet's dayside surge from a searing 500 degrees Celsius to over 1200 degrees Celsius in just a few hours. An oven hotter than molten rock. Its atmosphere can't handle the stress. It swells, expanding faster than a volcano's eruption. Shock waves ripple across its skies, igniting winds that reach speeds of 5 kilometers per second. That's 18,000 kilometers per hour. Faster than the speed of sound, faster than any hurricane on Earth by orders of magnitude. In those fleeting hours, the planet's atmosphere becomes a living, breathing entity. Water vapor, if it can exist at all, is torn apart by the heat. Molecules split. Hydrogen drifts away. Oxygen seeks refuge in chemical bonds, forming compounds that might never settle. Quartz crystals, which might once have floated serenely, evaporate in the heat. But they don't disappear. They swirl high into the sky, forming clouds of sand and glass that drift like cosmic dust storms. Imagine standing on a moon orbiting this planet. You'd see a world bathed in a fiery glow. A colossal gas giant, its atmosphere stretching out like a burning veil. The star's radiation would bend around its bulging shape, painting the darkness with an eerie red light. But HD 8006b doesn't stay there for long. Just as quickly as it arrived, it slingshots away, back into the cold. Temperatures crash, storms die, the atmosphere collapses inward like a balloon deflating. Peace, if you can call it that, returns to this chaotic world. But nothing about HD 8006b is stable. Its orbit is warped by the gravity of another nearby star, a silent, unseen companion that haunts this system like a phantom. It's the reason HD 8006b's path is so eccentric, so unpredictable. A gravitational ghost that reshaped this planet's destiny. Other worlds in this system never had a chance. Their orbits, their formation, all shredded by the gravitational chaos unleashed by this second star. A reminder that not every system can be calm. Not every star can be a sun like ours. HD 80606b is a world of extremes, a place where calm and chaos collide every 111 days, a place where the fury of a star meets the resilience of a planet. And in that battle, nature reveals its power. But HD 80606b isn't just an anomaly. It's a reminder that the universe has a sense of humor, a cosmic practical joke on any spacecraft that might try to visit. Because imagine trying to land there. 1 minute your ship is freezing in the coldest depths of space. The next, it's hotter than a pizza oven. Your instruments would melt before you could even say, "Houston, we have a problem." It's a place where even the best laid plans would melt away in a firestorm of shockwaves, hurricanes, and sand clouds. A place that laughs at the idea of stable weather. HD 80606b is the universe's way of reminding us, out here, even the most experienced travelers might want to pack a spare spaceship, just in case the first one bursts into flames.
Some planets are neighbors, others are practically roommates. Meet Kepler 36b and Kepler 36c, 2 worlds locked in a cosmic dance that would make even the best choreographer dizzy.
Both orbit a yellow subgiant star, one a little older than our Sun. But instead of keeping a respectful distance, these planets dare to flirt with disaster. Kepler 36b is a rocky super-Earth, a dense world 3.8 times the mass of Earth. Its surface temperature averages 700 degrees Celsius, hot enough to melt lead and ruin any chance of a summer vacation. Just beyond, Kepler 36c looms, a hot mini-Neptune 7 times the mass of Earth and cloaked in thick layers of hydrogen and helium. It's a gas world that dwarfs its rocky sibling, like a cosmic older brother always hanging around. Every 97 days, the two worlds draw closer, so close they're separated by just 1.9 million kilometers. That's 20 times closer than Earth and Venus ever get, practically a cosmic handshake or a potential head-on collision. At that distance, gravity goes wild. Kepler 36b feels its neighbor's pull, so strong it could cause the crust to crack and shift. Volcanoes might erupt in a chaotic symphony, a planetary reminder that close encounters can leave scars. Molten rock bubbles to the surface, creating seas of lava that never cool. Imagine rivers of red-hot metal flowing endlessly in a world that knows no peace. Meanwhile, the mini-Neptune Kepler 36c isn't just a bystander. Its own thick atmosphere bulges and ripples under the strain. It's like two wrestlers locked in a hold, neither one able to break free. The gravitational forces between them are 13 times stronger than the pull between Earth and the Moon. A constant battle of push and pull, an endless tug-of-war written into the laws of physics. But this dance is dangerous. Models predict that in 70 million years the two might collide, a cosmic crash that would obliterate both worlds in a spectacle of fire and debris. Imagine the fireworks, mountains torn apart, oceans of magma hurled into space, a planetary apocalypse that would make even the most dramatic Hollywood movie look tame. Why would the universe build something so unstable? Maybe because it can. Because in the vastness of space, even the most chaotic systems can last for millions of years, long enough for us to find them and wonder, how can such a delicate dance survive so long? Kepler 36b and 36c are a reminder that even in the heavens, some relationships are complicated. They're the universe's answer to the ultimate question, what happens when two planets can't keep their distance? If you ever thought your neighbors were too close, just be glad you don't live in the Kepler 36 system. Some planets wear their beauty like a crown. J1407b is one of them. A world so striking, it makes even Saturn's rings look like a cheap accessory. Astronomers first spotted J1407b back in 2012, orbiting a young star about 434 light-years from Earth. At first glance, it seemed like just another gas giant, another Jupiter-sized world drifting in the darkness. But then they looked closer, and what they found defied imagination. J1407b is surrounded by a system of rings so massive, so spectacular, that if Saturn were to stand next to it, it would look like a toy. These rings stretch outwards, a cosmic disk 640 times larger than Saturn's. Their outer edge reaches 6 astronomical units. That's about the size of Venus's entire orbit around our Sun. 37 distinct rings, each with its own structure and secrets. Gaps carved by hidden moons, tiny satellites that sweep the rings clean, shaping them into the magnificent patterns we see. Imagine standing on a moon, orbiting J1407b. Look up, and the sky wouldn't just be a canvas of stars. It would be crisscrossed with streaks of light, giant, glowing rings stretching from horizon to horizon. A night sky so bright, it might never truly get dark. But these rings aren't forever. They're fragile, slowly falling apart as gravity plays its game. Some particles lose speed and spiral into the planet. Others get slingshotted out into space, never to return. A cosmic clock, counting down the days until the rings disappear forever. But that's not the only secret J1407b holds. Astronomers suspect a hidden exomoon, an object big enough to carve a giant gap in the rings. A world roughly the mass of Earth, orbiting a ringed planet in a dance as old as time. Imagine living on that moon. Every night, the sky ablaze with light, the giant rings dominating the horizon, so big they dwarf the sun itself. A place where the night never truly falls, and with all that beauty comes danger. Tidal forces could rip at the moon's crust, unleashing oceans of magma and sparking volcanic infernos. Giant waves could crash against the shore, fueled by the gravitational embrace of the ringed giant. J1407b is a masterpiece of chaos, a cosmic wonderland that makes us question what's possible. Because in the universe, there are places where the line between beauty and destruction is thin, a reminder that the cosmos doesn't just build worlds, sometimes it builds wonders. And then, just as quickly, it tears them apart. We've journeyed to the edge of the known, to worlds that bend the rules, to planets that vanish from sight, to gas giants that flirt with their stars in deadly dances, colossal rings that stretch beyond imagination, and to planets that wander the void, forever searching for a home. These places are real. They're out there, orbiting distant stars or drifting alone in the endless dark. Each one is a reminder of just how strange, how unpredictable, and how incredible our universe truly is. We live on a small blue world orbiting an unremarkable star in a quiet corner of an ordinary galaxy. And yet, even here, we dare to dream of other worlds. We search the night sky for clues, tiny flickers of light that hint at something more, a wobble in a star's motion, a brief dimming as a planet passes by. And with each discovery, we add another piece to the puzzle. Another chapter in the story of how planets form, how they live, and sometimes how they die. Maybe one day we'll find a world like ours, a place where oceans kiss the land, where life rises from the depths. Or maybe we'll find something even stranger, a planet with 2 suns in the sky, or a gas giant with rings that light up the night. The universe is vast, and for every question we answer, 100 more await. So, as we look up at the night sky, let's remember that we are explorers, seekers of knowledge, voyagers on a tiny rock, searching for meaning in the darkness. Because in the end, every world, no matter how strange, reminds us of the same thing, that we are part of something bigger, something grander, and that the story of the universe is still being written. But maybe, just maybe, when we look at these planets, their bizarre orbits, their chaotic dances, their rings that stretch beyond imagination, we have to wonder. Maybe we're the anomaly. Maybe Earth, with its blue oceans, green forests, and teeming life, is the strangest planet of all. A world where the laws of physics align just right, where life took root and evolved, where a species looks to the stars and wonders what else is out there. Perhaps in the grand cosmic tale, we are the oddity, the miracle, the anomaly. And in that thought, we find both humility and wonder. Because maybe, just maybe, we are the universe's strangest planet and its greatest mystery.